I'm CK. Tonight we've got a fun little module from Frequency Central out of England. It's their Blades of Ingenuity kit. It's an attack release module and a triggerable LFO in a 4U package. So that sounds like it could be fun and could be interesting to interact with other things. So we'll put it together and see how it goes. Hope you enjoy the video. Here's the box. I purchased it from thonk.co.uk, where I buy quite a few modules. Even though they're in England, I get excellent service and excellent delivery speed, so it's the same as if they were next door. And it's by Frequency Central out of Coventry. If you've seen my channel before, you know I've done quite a few Frequency Central units. They're very, in general, they're straightforward builds, and they're very reliable, rock steady. So let's see what's in this box. Good, it's all paper packaging, so it's recyclable, it's not plastic bags. And we'll get the box ready for recycling. And let's see what's in here. Another sticker. I got plenty of Frequency Central stickers. Power cable. Nothing remarkable there. Trying to figure out which one's got the circuit board here. This will have the circuit board and front panel, I do believe. Yes, it does. Okay. Put that away for recycling. Let's take a look at it. Okay, we've got a dividing line here because we've got the attack release generator here, a pot for attack, a pot for release, and then there's a one-shot and a loop, and I'm not sure whether that's an LED or not. And here is LFO, and that's LFO speed, and then shape looks like straight front with a ramp to direct fall off, and a full triangle in the middle, so it's probably a switch. Attack release gate, attack release out, LFO reset, and LFO out. So I'm going to assume these two things are LEDs. Let's look at the boards. Rick Holt designed this one. Johnson Dunn did the PCB layout. This is the controls. Pot, switch, pot, switch, jack, 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 jack. Pin headers on either end, which I kind of like. And the LEDs, resistor, diode, and the resistor values are marked. The PCBs are a little bit thicker than most, which is just fine, though the solder points are through-hole plated. Let's look at the other side to see what we got. We've got, this is the logic side of things. Ingenuity is a small robotic helicopter operating on Mars as part of NASA's Mars 2020 mission, which, that's a nice little comment there, which, by the way, that little helicopter was supposed to fly 4 flights. It has flown, as of the time I'm recording this, 27 times. Brave little helicopter. So again, the Rick Holt and Johnson Dunn, and all the resistors have their values marked, so you could do this without a build guide. I don't even know if there's a build guide. Some electrolytic caps, power connector, TL084, that's an op-amp, and a TL072, another op-amp. So we've got a couple of op-amps, about 5 capacitors, and a bunch of resistors and a few diodes to make things not blow up. So that's the circuit board. Put it in there. And the front panel. Take a look in this bag. Now, one thing you do have to be aware of with these bags is sometimes components can get caught in the corners. So I like to rip the bag open before I recycle it. And we've got knobs, and we got these are like 80% perfect knobs. They're good quality plastic, and they've got brass set screws. They don't have an insert, which is the only thing that I would want better in my fantasies. Here's the jacks. One of the panel nuts is still on the jack. I'll take that off now so I'm not fighting with it later. Pin header, which means we're going to have to cut this because it'll go at either end. That's not one of my favorite things, by the way, cutting pin header strips. The male ones are okay, the female ones, you always lose a pin. I mean, it's almost like by design, you can't help losing a pin when you cut them, so I'm always a little sad about that. I'm taking all these washers and nuts and so on off now. Or maybe I'm not. Come on, washer! I'm not going to use a tab washer on a eurorack module, am I? So this is the 3-position switch for the shape of the LFO wave. That's the one-shot continuous looper switch. These pots, I think these pots are all 100K. And I think they're audio taper, but I'm not sure. I'd have to put it on the meter for that. I might not. So that's the mechanical components of the build. Now, so that leaves the electronic components in here. And again, this is very definitely where I want to take a close look inside the bag. Nope, nothing else in there. So we got 74148 diodes. Oh, that's nice. They even wrote the resistor values on the piece of paper. That's convenient for those who are not old and tired like me and memorized our resistor color codes 50 years ago. Foil caps. Where are the electrolytics? I'm not seeing electrolytic caps. Huh. So that's not good. Let me go back through the packaging. I'm looking. So the electrolytic caps seem to be missing from the kit, and they're it's 347 nanofarad. Hold on a second. I mean microfarad. So I go to my bench stock, and I can pull out. So what do you think? 10 volt, 25 volt, or 50 volt? I'm going to go with 25 volt. That's probably way overkill. Actually, I'm not. I'm going to go 10 volt. This is where I'm going to pause for a minute and go to their website and see if they list the values for these caps. Okay, the bill of materials lists 25 volt caps, which is overkill for eurorack, but it's safe, so I'll take 3 of those out of my bench stock here to let the soldering iron warm up. I won't. I'm just going to dive right in. And we're going to start as we usually do with all the resistors. And we'll start with the 47Ks, and I'll do one. Because you always want to check when you start a new kit, or you're building a kit from a manufacturer you haven't worked with in the past, you want to see little things like how much extra lead wire you have on the side of a resistor. Some of them, the board layout is such that you can squeeze the wire right next to the body. Sometimes you have to leave 1 to 3 millimeters of lead to have it fit in the holes. And this one looks like gotta leave about 2 millimeters on each side. I'm gonna guesstimate. So that's what we know now about the resistors. So we'll put them all on, and as is typical on my channel, when we're doing resistors, there's not much commentary to be had, so I will speed up playback and enjoy resistor time. Resistors are all on. Now we've got 7 diodes to put on, and we've got one here that's an interesting location for a diode. So we've got 7, so that's 1, 2, 3, 4, 5, 6, 7. And they kind of, be careful on this board, because they kind of alternate directions. And again, since there's not much to talk about with diodes except getting polarity right, and also this board, like it was for the resistors, is the holes are spaced a little far apart for the diodes, so you're going to have to leave much more shoulder on the wires than you might on some other boards, which bring them in a lot closer, bring the holes a lot closer together. So look at that, that's almost it's almost 3.5 millimeters on each side of the diode, which is actually quite a bit and not typical. But again, no commentary for the rest of the diodes. Now we'll put the IC socket on not on that board, on this board. 2 of them, one for the 84 and one for the 72. And as Dave pointed out to me the other day, TL084 is a replacement for the TL074, but apparently the 74 is a little less noisy. So I could drop a 704 in here. I actually don't know if I've got a spare in my IC box, but I probably do. But I think I'll just, since this is not directly in the audio chain, since this is a signal generator, a pulse generator, either the attack release or the LFO, and it's not directly affecting tone or audio, I don't think I'll do the replacement, because I don't care if there's a little bit of noise in this signal. And I'm sure the people who've measured the noise is infinitesimal anyway. I probably have more noise in other parts of the audio chain already that wouldn't even be noticeable. My patch cables are probably the weakest link in my audio chain anyway. Okay, now we'll put the power connector on. And it is keyed. But we do, even with the key and the notch on the board, I'm still going to double check that it goes to the stripe side. The negative 12 volt line is coming in correctly, and it is. Ow! Heated up my finger through that pin, as I often do. Alright, next step is to do the male pin headers. And as you can see, we've got to cut them. So I'll put it in place, make sure I've got all the pins accounted for. And I'll run this back out. This is always the tensest part for me, cutting the pin headers to length. And these you definitely want to have aligned properly. So we'll tack that pin down, take a look. It's a little bit off, directly perpendicular. There. Now it's good. And we'll do the other end too, and then solder all the pins up at one time. Maybe I'll go in this way. Line it up. Put my thumbnail there. You'll notice I'm using a regular pair of cutters instead of my flush cutters, because I don't want to dull the flush cutters. It all looks good. Now we'll do the caps. And just to show, as usual, these components that come on strips, don't try and fight them out of the tape and cardboard. You'll just get frustrated and pins will get bent and all that. Just cut them off. The only time you have to worry about that is if they're polarized electrolytic caps, because you're losing the long short leg negative positive indicator, but the electrolytic cap still has the negative stripe on the body of it, so it's not that big a deal. You just have to remember. Oops. These two film caps that I'm putting on. are not polarized. Now the 4 or 3 replacement, 47 microfarads, and I checked with Thunk, who I bought this kit from, and Frequency Central packed the kit. Thunk just fulfilled the box, so they've passed on my comment that these electrolytics are missing from the kit, from actually 2 kits, because I got another one of these. And they'll pass that along to Frequency Central. And we'll put the op amps in. Straighten the legs out a little bit on the corner of my workbench. Make sure the notch matches the notch silk screen on the board, not the notch in the socket, because I have in the past gotten sockets backwards. So the silk screen is the truth, the socket is kind of a hint, if you know what I mean. Okay, so the electronics board is done. So put that aside and start working on the jacks and knobs board up. Didn't trim one lead off. Now, he wants us to put everything on here before we put the pin headers on. I'm going to put the pin headers on first, just because I feel more comfortable that way. And I'm going to get some bigger pliers, cutters for this, because the pin headers are... I've had these diagonal side cutters longer than many of you have been alive. I always hate this part because you always lose a pin when you do female pin headers. Oh, and there we go. Yeah. I cut that wrong too. Well, I hope I have enough for the other end. I do. It's one thing I never have enough of is spare pin headers. I gotta order like a couple of yards worth of them. Because I'm always stressed about cutting the female ones. Because you just can't cut them without losing one pin, the way they're designed. I'm just going to set this in before I get to the other end. And there's a little, that's what it looks like inside. That little pitchfork is what captures the male pin header when you mate the 2 boards. Okay. That's perpendicular. So let me solder these pins up. I'm just going to double check here, make sure these look good. Yep, they look good. Now the next step, we'll lay all the control components on. Now before I put the controls in place on the board, I'm going to check that these diodes actually work. So the way I do that is I take my meter and I put it in, and I untangle the cables, the leads from my soldering iron cable again. I put it in continuity mode, which is the mode where it beeps when there's connectivity or conductivity, and that means that there's a small amount of electrical current going through the probes. So what we can do is we can put our negative probe on the negative lead and our positive. First I'm going to splay these out just a hair because it's giving me fits right now. And you see it lights it up. Even the small amount of current that the meter's putting out is enough to light up the LEDs. So you can, oh, the leads are touching. So you can make sure that the LEDs are working before you put them in. Always frustrating when you get something together and an LED doesn't work. Now on this board, they're using the convention of a square solder pad to indicate the negative lead on the LED. So there's a couple of LEDs. Just hold them in place for a second. Now we'll put all the little guys on. First thing we do is the pots, and we do the pots first, and they're all the same. They're all 100K. We do the pots first because they kind of clip into the board, click in, and if you put jacks on first and don't solder them, which you shouldn't, the clicking of the potentiometers into their lock position can often dislodge the jack, and you're chasing back and forth. Let me get these pliers out of the way. Got to straighten these legs out. They were bent a little bit in shipping. Now we've got the two switches. Again, we've got the 3 position and the 2 position, and the 2 position goes up on top, and they're a little tight too, which is good. It doesn't matter which way you put them in. They're not polarized per se, if you want to use that term. Misuse that term. Uh-oh, that's not going through. Did I get solder in there? No, I did not. It's just being recalcitrant. Come on, I don't want to bust the circuit board. Gosh, that's not going anywhere, is it? I mean, I'm going to have to squeeze this in with tools. And then one of the diodes came out, LEDs came out, of course. That's really tight. I think it's down far enough. Put this LED back in so I don't forget. Now the 4 jacks. Oops, I forgot to take the panel nut off that one. I'm glad I noticed that before I put the front panel on, or else I would have been very confused. Huh. There's one other thing I'll show you in a second here that I just noticed. These pots have a little locking tang here, which is sticking up a little bit from the surface of the pot, and that's going to keep the front panel from going in the way I want it to. So let me get another pair of pliers. I just noticed the top camera had gone off for a second, or I hadn't kicked it on, I forget which. So let's just get a better picture of what we're talking about here. There's all the jacks, the switches, the pots, and what I'm talking about right now is right here. It's a little tang on the top of the pot. I'm going to take my carbide tipped cutters and nip that off. I'm using the carbide tip because they will not be damaged at all by cutting through metal. Carbide tipped pliers, cutters are more expensive than plain steel, but they're worth it. You don't use them a lot, but when you do use them, you're protecting your investment in your other tools by using these pricey tools. And the other thing is, you're going to use them for the rest of your life. They're not going to go bad. Okay, let's get the front panel and put it on and try and get it through all these nips. Don't put it on the wrong way or else you'll look silly. It's a little tight around this switch. This hole is not quite big enough for the switch that we've got. I'm actually going to, that's just not working. I'm going to remount this hole a little bit. I'm going to do that off camera. Changed my mind, I'll do it on camera, because what's the point of doing it off camera? Just a nice round file. Just to open the hole up a little bit more. Doesn't need much, but it is too tight to go smoothly. On that threaded shaft. Let's see if that's enough. Yeah, okay. That goes on well. Now let me get this piece of paper out of here with the aluminum shavings on it off. Now we can finish up sliding this down. Get everything aligned. Oops, ha! I missed another one. I thought I had taken all these panel nuts off, and I didn't. Now I'm gonna put the panel nut on this potentiometer on in the center here to stabilize everything, because the potentiometers have locking legs on the side, so that's enough stability for soldering, because you just want it a little bit tight. You don't want it super tight. And I'll push. These LEDs have little shoulders on them, so they set up in there like that. And now put it over here some way. It's the best way. Oops. God bless America. I pushed it too hard down trying to get it into the holder, and this pot came loose. So this time, besides getting the nut finger tight so I don't do this again, I will go ahead and solder one of the pins on that pot so it doesn't do that again, and everything will be very secure. Okie doke. Everything looks good. Put it in here again. Actually, why don't I try this? Now we'll solder everything up. Alright, everything is theoretically soldered up, but what we're going to do is we're going to go through all the solder joints, make sure they're all done, they're all looking good, and nothing is bridged. I use an index card to look, because that isolates just a couple of connections at a time, so my visual circuitry is not trying to look at a whole board all at once. And there is one leg right here that I didn't solder. It's not critical. These are not electrical. They're support, but may as well do it anyway. Now before I join the boards, I'm going to put the power cable in, like so. Now comes the time in sprockets when we mate. And I'm going to, this is one place where I am going to go look at the picture to make sure I'm mating this correctly. And he doesn't have a picture of it mated correctly. So I believe if we look at top, top, bottom, bottom on page 1, which is just the PCBs, nothing assembled onto them, I think this is the way it goes. So we're going to go with that. Here we go, squeeze it together. Pins are all in correctly. Now we'll speed up the cameras a little bit as I put all the panel nuts on. Okay, so if you've come to this video because you looked up how do I mate the boards on a Blades of Ingenuity, here's how it is. The pots and the TL084 are at the top. So that's the way it looks like from the front, the side, the back, the other side, top, and bottom. So that's it. Not a bad build, pretty quick. So let's put it in the rack and see how it works. So for all of you who were yelling at the screen, you forgot to put the knobs on. You're right, I noticed it after I put it in the rack, so I put the knobs on. I'm backed out a little bit for the moment because I'm going to be, instead of using a squid cable, which I usually do to tap off for the oscilloscope, I'm actually using this multi from Synthrotech that I built the other day. A build video should be up by now. So what will be happening is the gate, the attack release, is going in to number 3 here, feeding the frequency central more VCAs and the scope, and the LFO is going in here, and I'm putting it into frequency modulation as well as the scope, but frequency modulation on the VCO for right now. I don't know if that will show enough. If it doesn't, we'll figure something else out. So I'm going to zoom back in now. Now I do not know why I'm going to actually disconnect the LFO because it's kind of driving me crazy right now. I don't know why the attack release is doing what it's doing. This diode is in backwards, and I'm not using the top camera right now because I've got it set up over there, pointed at the oscilloscope. So I've got to swap this diode and make sure that the diode's still good. I've got plenty of spare. Oh, gosh darn it, my soldering iron cable's wrapped up in something again. I've got plenty of spare 4148s. So even if this does not test good, we'll be fine. Just heat that up and pry it out a little bit. Yep. Now I got to use my needle nose for the other side because there's no... Put that over there for the second. Put my meter here. And we're going to make sure it didn't blow up. And we should get something here. Oh yeah, that's just dandy. Let's check to see. Reverse should be 0. It is. Make sure I'm getting good contact. Come on, little guy. Yep. So the diode is good. So we'll put that back in somehow or other because I really don't want to take this front panel off to do it. I should be able to drop it in there. Okay. That's fixed. I've checked the other diodes. They're all oriented correctly. So we'll fire this up again. Okay, so the diode seems to have fixed things. Imagine that. So let me bring up the oscilloscope. And one thing you might notice, the LFO is set to a very slow rate, but it's causing a ramp, which is kind of neat. If we put it in the, I'll show you that in a little bit. But first, let's look at the AR. That will be the yellow line. So that looks about normal. Let's change it around a little bit. Make the attack higher. And the release drops right off. Make the release higher and the attack shorter. That's interesting. With the release higher, it's self-oscillating. I take the release all the way down, and it doesn't self-oscillate. Of course, I can flip it over to loop. You can have very long attack and delay loops. I'm going to add a little more note values. That's interesting that the release is doing that. Taking the attack all the way up does not do that. Okay. Now let's plug in or turn on the LFO and look at that. I mean, I'll just turn up the rate and you can see the LFO is really nice. So let's put that in as frequency modulation on this. Having a very short attack, and we'll go the other way. So that's pretty neat. I'm going to go back to loop here. Now back to one shot, and the FM is down all the way, so it's not doing anything. Let me turn that up. That's interesting also. See that little hump at the back of the release? I wonder what that is. Huh. Well, in any event, after messing about a little bit, we got it working. And it's a very convenient unit. Obviously, having a 4U, LFO, and attack release segment, really useful. So I can recommend this. Just put it together right. So that's it for this one. Hope you enjoyed the video.